Now we're on page 3. This goes from question 11 through 15, really. And we're asked to find the least common denominator for these two fractions. So the first thing you want to do is factor both denominators and see what they already have in common. You notice what they already have is the x minus 3. So this one is missing the x plus 8. This one is missing the x plus 5. But if we were going to add these, we would need to make the denominators the same and as simple as possible, ideally. And what we would use would be a denominator that would accommodate every different factor. That's a whole lot of words, but here's the answer. The answer is just a combination of all the different factors of the denominator. So we need the x plus 5, x minus 3, and an x plus 8. Notice we don't need the x minus 3 twice, because if you use that combination, that's going to not only make it a common denominator, but it's going to make it as small as possible. Now, here comes that same objective right here. Before we can add these, we need to get these to be the same. And the strategy for that is first factor each denominator. So this one factors in the 3x minus 2x minus 2. The one on the right factors in the 3x minus 2. I'm sorry, I got that wrong. This one factors 3x minus 2x plus 2. Yeah, see, there's 6x minus 2x makes the plus 4x in the middle. And this one, they're both negative. Sorry, I had a dizzy spell or something. And there's the numerator 2. So, what is this one missing that this one has? This one is missing the x minus 2. So multiply the top and bottom by x minus 2. What is this one missing that this one has? This one's missing the x plus 2. And now that we've got the common denominator, 3x minus 2, x minus 2, x plus 2, we can remove these parentheses and then we can add. So this becomes 4x minus 8 over yada yada plus 2x plus 4 over blah blah blah. And then if we add these, what do we got? 6x, 4x and 2x, 6x, and negative 8 plus 4, that's going to be minus 4. And the denominator is the 3x minus 2, x minus 2, x plus 2. If we factor out a 2 here, let's do one more step here. 2 times 3x minus 2 over 3x minus 2, x minus 2, x plus 2. There's a cancellation. And so our finished, most elegantly simple sum is that 2 over x minus 2, x plus 2. Okay? Now question 13, there's not enough room on this sheet of paper, so I started writing it out over here. 13, we had this x over x plus 2 plus 8 over x plus 4 equals x minus 12 over x squared plus 6x plus 8. We're asked to solve for x. We're asked to find the value of x, or values if there's more than one solution. That would make this true. We might want to start by saying we have excluded values. We can't divide by 0, so we can't use a negative 2 or a negative 4. If we factor this side, the factors turn out to be those same two expressions, x plus 2, x plus 4, so there's no need to write that out. So to get rid of all the fractions, to clear out all the fractions, we need to multiply both sides of the equation by the least common denominator of all three fractions, which would be the combination x plus 2, x plus 4. Remember, this multiplied out is that other denominator. So, on this side, notice the big brackets. I'm using the distributive property. First, I'm multiplying this times this. And the x plus 2's cancel, and we still have an x times x plus 4. Then plus, multiplying these together, the x plus 4's cancel. We still have an 8 times the x plus 2. Takes care of the left side. Right side is just beautiful because remember, this multiplied out is exactly that. So this totally clobbers that, leaving us only x minus 12. And now we concentrate on solving this. Remove the parentheses, you get x squared plus 4x plus 8x plus 16. And if I combine those x terms, I get x squared plus 12x plus 16 equals x minus 12. And now I'm going to subtract an x from each side, and I'm going to add a 12 to each side. And then I have x squared plus 11x plus 28 equals 0. And we can factor this and use the zero product property to solve this quadratic. And this factors very nicely. X plus 7, x plus 4. The solutions to this quadratic would be negative 7 or negative 4. And I'm going to cross out the negative 4. Why? Because we can't use negative 4. So the only solution is a negative 7. In question 14, the one about the computer sending email. Again, there's not enough room on the paper really to do it, so I wrote it down here. I'm going to say x represents the number of minutes it takes the faster computer working by itself. So what happens in 1 minute? The faster computer gets 1/8 of the job done. The computer that takes 30 minutes to do the job gets 1/30 of the job done. It says that working together, it takes them 10 minutes, so working together, they get 1/10 of the job done. So if we solve this for x, that'll tell us what we want to know, how many minutes it would take the faster computer working by itself. So I'm going to multiply both sides by the least common multiple of x and 30 and 10. And that would be 30x. And on this side, again, distributive property, the x's cancel, and you have 30 times 1 is 30. Then plus, the 30's cancel, and you just have x. And on the right-hand side, 10 goes into 30 3 times, so we have 30x. I'm sorry, 3x. I am a hot mess today. I'm really sorry. We have 30 equals 2x. One mistake after another. Divide by 2. You get 15. So 15 minutes. 15 minutes for the faster computer working by itself. And finally on this page, question 15, we want to write an equation for this. U varies jointly with P and D and inversely with W. So remember, jointly just means multiply by your unknown constant K and multiply by both variables that it varies jointly with. Inversely means divide by that variable. So I can write U, here's my constant of variation or constant of proportionality. Alex likes that terminology better. Varies jointly with what? P and D. And inversely with W means you divide by the W. That's nothing any fancier than that. Okay, so that concludes page 3.